Hello all. Today I'm back with the method of strain energy on trusses. As we know, strain energy it's equal to half into stress into strain into volume, that is half into sigma into E into V. Then we can rewrite in terms of load, area and Young's modulus E, and we will get it as half into P by A into P by AE into volume, it is A into L. That's equal to half into P square L by AE. Okay, then it's this equation is for only one member, and then for a number of forces in a truss we can just take the summation, that is U is equal to summation half into P square L by A. Then what is the equation or method of least what states it states that the partial derivative of strain energy with respect to the redundant is equal to 0. So this is the equation for partial derivative, this is the equation for strain energy. So just take the partial derivative with respect to the redundant, that's equal to summation of half into, take the partial derivative of this term with respect to redundant. So I chose R as a redundant, so that's equal to half into 2 into P into dou P by dou R into L by A is the partial derivative of strain energy with respect to the redundant. Then by principle of least work we can just equate the term into 0, that means half into 2 is just cancelled, the remaining terms are summation of P into dou P by dou R into L by A is equal to 0. So this is the equation for solving a truss with the redundant. Okay, then where P is the forces in members of the truss and dou P by dou R is a partial derivative of the internal forces in the members with respect to the chosen redundant. Okay, so this is the equation that you need to know to analyze a truss by using the method of strain energy, that is summation of P into dou P by dou R into L by A. That is first of all find out the term P, that means the internal forces in the truss, then take the derivative with respect to R, then find out L by A, then take multiply P into dou P by dou R into L by A, then add all the terms for all the members, that is summation of P into dou P by dou R into L by A equal to, then equate to 0. Okay, so let's solve a problem, that is find the forces in the members of the member BC of the truss shown. All members have same cross-sectional area and modulus of elasticity. So you can see a truss here, and the members are AB, BD, DC and CA, and also AD and BC are the members of the trusses on which the one end is hinged and the other end is roller supported. Okay, so for a hinged support we can say HC and VC are the reactions, where HC is a horizontal reaction, and here you can see an external horizontal reaction towards the rightward direction 10 kilonewton. So HC I just drawn into the rightward direction, that's equal to minus 10 kilonewton. Okay, or else you can drawn into the left side direction, that's equal to 10 kilonewton positive. Okay, then VD is a reaction at the joint D. Then we know that the external redundancy in this case is 0, and then go for internal redundancy. What's the equation for that? It is m plus r greater than 2j. Just find the term m plus r and 2j, then take the difference. M plus r is 6 plus 3 and j is a number of joints, and that's equal to 4. So 9 greater than 8, that's equal to 1 is the internal redundancy, internal indeterminacy or redundancy. So we have to find one redundant for this truss. So in the case of internal redundancy we have to choose any of the internal member as the redundant. So I chose BC as the redundant member. Okay, in case of external indeterminacy we have to choose any reaction as the redundant. So here we have internal redundancy of 1 degree is there, so I chose BC as the redundant capital R. So I have to draw the figure with the BC as capital R tensile in nature. Before that, we can just apply the equations of equilibrium, that is sigma fx equal to 0. Then we get hc equal to minus 10 kilonewton. Then use sigma fi equal to 0. Here there is no vertical loads are acting, therefore vc plus vd equal to 0, which implies vc is equal to minus vd. Then take summation ma equal to 0. As we all know, for a truss member, there is no moments at the joint. So we can simply equate MA equal to 0. Then this will become 10 into 3 minus 4 into VD equal to 0. That is VD equal to 7.5 kilonewton and VC is equal to just negative of that value, that is minus 7.5 kilonewton. So coming to the analysis of truss, we need to find all the P forces. Okay. We need to find all the P forces by taking the truss. Okay, so I just draw the truss and just write BC is equal to R tensile in nature, that is it is away from this joint C and it is also away from the joint B. Okay, now mark the 10 kilonewton load and then take each joints and find out the member forces in terms of this capital R. Okay, that is for the joint B, here we have member AB, member BD and also the redundant. Okay, so consider the member AB, that is PBA and PBD, where PBA is the force in the member BA and PBD the force in the member BD. So by using the equations of equilibrium, we will get PBA equal to minus 0.8 into R and PBD equal to minus 0.6 into minus 0.8 into R and also PBD equal to minus 0.6 into R. Okay. Now take the next joint, that is joint D, then find PDA equal to R minus 12.5 and PDC is equal to 10 minus 0.8 R. Then take the joint A and also find out PAC, that's equal to minus 0.6 R plus 7.5. So these internal forces are called P forces. So just draw the table, write the member and its corresponding length, then write the P forces, that means the member forces that we already find out using method of joint. Okay, then take dou P by dou R, that is take the derivative of this terms with respect to the redundant capital R. So what is the derivative of minus 0.8 into R? Just minus 0.8. Okay, derivative of this term is minus 0.6. Take the derivative of all these terms. Then find out the next column, that is P into dou P by dou R into L. Just multiply P into dou P by dou R into length. So this is the column for P into dou P by dou R into L. Then the last column for finding the actual member forces by substituting the R value in the column for P. Okay, here we have a column for P, that means the member forces. We have to find out this R value, then minus 0.8 into R value will be the answer. That means the original member force. So for that, use the principle of least work, that is take the summation of P into dou P by dou R into L by AE. We will get the summation of P into dou P by dou R into L is equal to 17.28 R minus 108. That divided by AE is equal to 0. Okay, so just equate that term into 0. We will get 1 by AE into 17.28 R minus 108 equal to 0, which implies 17.28 R minus 108 equal to 0. That implies R is equal to 6.25 kilonewton. So here we got the redundant R is equal to what? 6.25 kilonewton. Then just substitute the R in the column for P, that is minus 0.8 into R is equal to minus 0.8 into 6.25 is equal to minus 5. Then minus 0.6 into R is a member force in BD, that's equal to minus 0.6 into 6.25. Okay, minus 3.75. Likewise, find out all the actual member forces. That means the member forces for AB, BD, CD, AC, AD and BC. So these are the actual member forces in the truss. Okay. Hope you all understood this problem. It's a simple one. Just by heart the equation, that is summation P into dou P by dou R into L by A is equal to 0. Okay. And just try to solve the problems. Just try to solve each problem. Then you will get familiar with this. Okay. Thank you.